Hi everyone, and welcome to this level 1 training of our Atellio family. Today we will be looking a bit deeper in the whole family range, going from our network processors, our network control panels, our audio wall panels, and finally our paging table. Let's focus on our audio matrix processor, our Luna. Here on front, you will see power button, rotary button, display USB connection. It comes within two models. On one hand, we have a flexible Luna and a unified Luna. They may appear the same, differences can be found on the back of the device. Let's overview them. So besides a primary power, we have a 24-volt backup power supply. The Luna F has a double network connection. You can use for control and your primary Dante. The second one, redundant setup for Dante. But you can also focus on the first network connection for your Dante and do the control on the second network port to keep things separated. If anything happens and you need to trigger, let's say, a fault contact, we have a toggle relay, normally open, normally closed. You can also control the system RS-232, RS-485, and USB-C connection for file transfer, updating, or external storage for, let's say, voice files. Focusing on the input section, 8 balanced inputs with phantom power, 8 balanced outputs, but also flex channels for the Luna F. Flex channels that you can define as an input or an output, and they also carry phantom. They also have GPIO, general purpose input-output. They're connections, not seen as a contact, but you can check for a high or low state, edge triggering, more of that later on. The U, 24-volt backup, is the same, but only one network connection for primary Dante and control. Fault contact, RS-232 and 485. USB-C, the input section is a bit different. There, fixed 12 inputs, balanced with phantom, and 8 outputs. The GPIO, slightly different, 12 fixed inputs and 12 fixed outputs. Looking at the block schematic, which basically gives you an overview of all the different blocks, such as your input block, processing block on the input, zones, 32 monozones or 16 stereo zones, your output processing, and finally your outputs themselves. Also your Linux system and your AEC. Connected to the Linux system, of course, your GPIOs and everything else. Now, what about controlling and configuring the Luna? Well, of course, this must be done in Audac Touch. This is the main interface. And as you can see, we tried a graphical representation of the Luna. Basically, you will see the same as in the block schematic, which makes things easy to configure. Remember Audac Touch, freely available platform for different operating systems. It can create your custom dashboard in a minute. Very easy without programming skills. Audac Touch will be the platform to control your device. Let's focus back on that block schematic and take a deeper look of every block itself, starting with your input section. Now on the input block, we provide a lot of input channels. We have our balanced inputs, we have our flex channels, but also your Dante channels. And depending on the license that you have on your Luna, it can go up to 64 Dante channels. Your operating system will also provide inputs such as voice files, messages and stuff like that. And we even throw in a generator if you want to do some testing, like white noise, pink noise, and a sine generator. So a lot of input connections. And even more, on every input, you can do input processing. Let's focus on that one. So, following this signal path of an input, you have your gain control, AGC. You can have a low pass, high pass filter, wave tune, anti-feedback, and a volume setting. More in detail, your gain can handle input signals up to 22 dBV or 24 dBu, and also a fixed line mic level range. Your AGC has a noise gate. Your whole decay attack timing can be adjusted to target level and maximum gain. Now in the Luna, the gain control and your AGC will be actually one setting. Or you go for a manual gain adjustment, or you choose for the automatic gain control. Low pass, high pass filtering, 2 filters, so you can create low pass, high pass, or a band pass filter. They're second order filters. But also wave tune, which is basically your 7-band EQing, parametric, on every input. Also provided an anti-feedback function, 12-band with permanent filters and some dynamic filters. And last, on the input, you will have a volume control with a minimum and a maximum limit. Back to the block schematic. After I did some input processing on my inputs, I have 2 choices. Or I can enter a zone or go directly to an output. But let's first focus on our zones. Now, remember here that a zone is not a physical output yet. It can be assigned to an output. We'll see that later on. But a zone is actually a block that you can do extra processing, paging, voice files. Let's take a look. First of all, we need to do some mapping. I have a lot of inputs, and in my zone, a lot of inputs can be mapped, 16 in total for each zone. And you can have up to 32 mono zones, or 16 stereo zones, or anything in between. What can be mapped? Well, logically, all of my analog inputs, all of my Dante channels, but also if I exit the zone, I can reroute it as an input to another zone. And finally, your acoustic echo cancellation channels can also be mapped to that zone. Then we enter the mixer. Since we can map 16 channels, we have a 16-channel mixer with a talk-over function where you can choose your talk-over source level and also a recovery fade. But there's more. We have a minimum and maximum volume limit on that zone, which is ideal if you have SPL restrictions. Paging volume for a default paging level. And important here is that any paging table that's connected to your Luna can actually overrule the default paging level. Let's say you have a normal message or a broadcast that you want to do, speech, but on your paging table you also have a voice file or an evac message that needs to be played at a higher volume. The paging table can overrule the standard default paging volume. And of course voice files, which we made a bit easier now. You can use whatever you like, MP3 or WAV files. and do some priorities on that. They can come from your internal storage, from your SD card, which is basically the SD card that holds the operating system, but also your storage, logging, and stuff like that. So a lot of space that can be used. But if you have more, you can use an external storage by the USB-C connection. The voice file can be triggered either by calendar, a timed event, but it can also be triggered by your GPIO contacts, connections. And finally, 3 steps in your zone are priorities, with 4 priorities for each zone. And remember, we had 32 zones in total. But also wave tune on your zone. Again, 7-band EQing parametric. And also we added a compressor limiter with an attack release, a threshold, and a ratio. What about those mono and stereo zones? Well, you can have 32 mono zones, 16 stereo zones, which basically a stereo zone where we take 2 side-by-side inputs and merge them into a stereo zone, or you can have anything in between. The choice is yours. When I exit my zone and I want to assign it to an output, before I do that, I can do output processing. Let's focus on that one, where first of all, I need to do again a mapping, meaning that I exit my zone and I can map to a physical output, flex channels, analog outputs, or I can also direct from the input to the output without going through a zone. It can be Dante inputs, but it can also be your acoustic echo cancellation outputs. You can give a volume offset for each output, and that can be ideal if you say, I have one zone, do some processing, and I go to the output, but maybe it's a stereo zone, and I want to do a balance control, left-right, or it could be the offset between satellite speakers and a subwoofer channel, all coming from the same zone. A low-pass, high-pass filter, 2 filters, again, high-pass, low-pass, or a bandpass. Second-order filtering. And even more, where we talk about wave preset, which is actually your 12-band EQing. Maybe you want to send out that zone signal to a certain speaker and already give it the wave preset setting, the filter setting, which we think now the speaker will sound at its maximum performance. Or you can assign a delay. If you have multiple speakers connected, coming from the same zone, but every output needs to have a different delay. Acoustic echo cancellation is a licensed feature. It's a 4-channel where you can have on your near-end input can be either an analog input, you can take a channel from your Dante, or it can be a zone output. Let's say that you have a very small meeting room with 3 microphones, and you first want to mix them together and then feed them into the acoustic echo cancellation block. On the near and far output, can be an analog output, a Dante output, or you can reuse it as a zone input. Remember that this is a licensed feature and not yet activated on the Luna F. Before we go to the Linux part, the operating system, it's important to understand that no matter where you come from your input block, entering a zone, or going directly to your output, everything in this block schematic is interconnected, and the choice is yours where you want to go with your signal. You don't need to enter a zone. And remember, a zone is not a physical output. A zone can be assigned to multiple outputs. All this is possible. So what does that Linux operation system does? Let's take a look. Well, first of all, GPIO contacts or connections are connected to the operating system, but also your messaging and voice file, your timer scheduling. Let's focus on that one. Lua scripting. What exactly is that about? Lua scripting, in some cases, you might want to have a configuration in your Luna, and you say, okay, but I have a special condition. I have a special condition that I want to check before the Luna does anything. Why not write your own code, your own macro code, and check for, let's say, if input signal 1 reaches 30 dB or minus 30 dB, then something else must happen. This can be done by Lua scripting. And Lua scripting gives you access to events, timed events. It can give you access to the GPIO, you can check, but also to your audio blocks and permission configuration. For your messaging and voice file, same story there. MP3 and WAV support. You can do priorities, USB storage, internal storage, but also triggerable by GPIO or by calendar. And now comes the fun part, where I know most of you will be very happy with. The timer scheduling, or the internal clock of the Luna, since it's Linux based, we can handle now time zones, NTP support. We can do automatic daylight saving time, one-time events or recurring events. This was not easy in the past because with the time zone and the automatic daylight saving, some of you still needed to go out there and change the clock when summer or winter time arrived. Also connected to the Linux system are your GPIO connections. GPIO connections for the Luna F and the Luna U are a bit different. For the Luna F, we stick to 24 flexible connections. So you can have an input or an output. For the Luna U, we fix 12 inputs and 12 outputs. Please notice that also on the GPIO connection on the back, you will see you have 24 volts available. So if you want to trigger a connection on the GPIO, you can take power from that one. So what is it about? What can GPIO connection actually do? It can monitor that connection and see if it's in a high state or a low state on an input. It can also do positive or negative edge triggering. And even more, you can check for a certain level. If that connection reaches 10 volts, then something must happen. They're clamped to 33 volts, meaning that if you use the 24 volts of the Luna, you're safe. If you want to use an external power supply and inject that to your GPIO connectivity, make sure it's not higher than 33 volts. Although they're internally clamped, best to avoid that. On the output section, it's an open drain. It's an open drain MOSFET that we installed, allowing you to simply switch maybe lights or a relay or stuff like that. They're not meant to switch high loads. If you want to do that, always use an auxiliary relay. What about controlling your system and configuring it? The way to do that is, of course, Audac Touch, but we also have network control panels that can control your system, and limited control by front on the Luna. But of course, you want to use Audac Touch. It gives you the most possibilities and options to configure and controlling that system, whether it's configuring or creating an entire dashboard. The second product that can control your system are our network control panels. The NCP 105, with its 4 buttons and 1 rotary button, and the RGB ring, allows you to control not only an Audac device, but also a third-party device. We have 4 custom programmable buttons. You can program the rotary button. You can even customize the RGB ring. They're PoE powered. So let's take a look of an example. Let's say I want to use an NCP and I want to change the input and the volume of a certain zone. Meaning that the 2 buttons on the right will change my volume, 2 buttons on the left will change my input, and the rotary will act as a volume and a mute button. How do we program this? Well, the way to do that is Audac Touch. And Audac Touch will actually put in its configuration the same wall panel. And it's up to you to assign to each button the correct function. In this example, volume and input. And the rotary will have a volume and mute selection. Now this is a 1-layer setup. Very easy. But you can also make a multi-layer setup. Let's say I want to control 2 zones. And with the buttons, I select what function I want to assign to the rotary button. Zone 1 volume. The rotary button, it depends on the selected button. Because if I push left low, it's zone 2. Top right, zone 1 input selection. Top right bottom, zone 2 input selection. So we need to make a 4-layer setup that, depending on the button I press, the rotary will be assigned with the correct function. Again, in Touch, this will be very easy to do. It will give me 4 layers. And I program each button either to jump to the next layer or go back to the previous layer. And on each layer, I will program the correct function for the rotary button. Multi-layer setup. So NCPs are wonderful devices. They can control basically the entire Audac family that has that network connection. And beyond, non-Audac devices, third-party devices. Remember, UDP TCP connection. The last option can be done by front control on the Luna itself. Thanks to the rotary button and the LCD display, we can give you a menu structure. Now, this will be limited because the Luna has so much possibilities, but we can show, for example, the input section and the output section, showing if there's signal present or not, if phantom was enabled, if an input is clipping. That can be shown on the front control, together with a menu structure that can be activated by the rotary button. An input overview or a network setting. 2 examples of simple on-screen information. When we talk about our network wall panels, where audio is involved, Dante, they all have one thing in common. They all have Bluetooth functionality and 4-channel Dante. And we offer you 5 different panels, which we will later on study more in detail in the block schematic. Now, let's take one of those with the 2 buttons, an NWP222. As you can see, there are 2 buttons on front, And those buttons can be either custom programmed for Bluetooth functionality pairing by pressing both of them, or change the XLR input from mic to line level. In case you don't want people to tamper with the wall panel, you can also disable them and even adjust the brightness of the LEDs. By studying the block schematic, we see that we have two XLR inputs with phantom power, Bluetooth connectivity, and a 4-channel Dante input. And again, on all of these inputs, I can do input processing. I can have a gain control and an AGC and noise gate and a volume slider on the Bluetooth and Dante inputs. And on the XLR input, where you want to plug in a microphone, you have a gain control, your AGC, but also wave tune if you do some EQing. And also a volume slider. And the wonderful thing about these wall panels is, since I have all these inputs, they also have mixing functionality. So looking at the output processing, I have a mixer setting, a volume setting, and a gain setting. And from there on, it's up to you to decide on which Dante channel you want to send those signals out. It can be a mix, or it can be 4 individual channels. Our second wall panel is the NWP222, which is basically the same as a 220, except it has additional 2 XLR outputs. Let's take a look at the block schematic. Again, 2 XLR inputs, Bluetooth input and Dante channel inputs, with some input processing, which is basically the same as a 220. We go to the mixer, the volume setting and the gain setting, and from there on I have multiple possibilities again on the Dante channels to go out or to go to the XLR outputs. Let's say you want to have a recording or a monitoring on that wall panel. It can be used for that. The MWP300 is a bit different. Instead of XLR inputs, it has the mini jack 3.5 input, stereo. And looking at the block schematic, it's the same story. Again, Bluetooth, Dante in with the input processing, and on the mini jack also gain, AGC, wave tune and volume. We enter the mixer settings, volume, gain, and put on the Dante channels out whatever you like. For the NWP320, which has an extra XLR and mini jack input, Bluetooth and Dante channel in, it's basically the same. You will see always the same pattern on those wall panels. Looking at the block schematic, XLR input with phantom, mini jack, stereo input, Bluetooth input, Dante input, again input processing, and basically everything that is not Bluetooth or Dante will have wave tune on board, including the mini jack. We enter the mixer with a volume and a gain control, and we put it on the Dante out channels. The last one will be our NWP400. The NW400 in the block schematic has an USB input, stereo input, again Bluetooth and Dante in. The USB input, however, does not have wave tune on board. We enter the mixer and we go to the Dante channels out. So how can this be configured in Audac Touch? Let's take a look. Let's take an example of an NWP222. It has 2 XLR inputs, the Bluetooth and the Dante channels. On the output section, we have 4 Dante channels out and also our XLR outputs. And depending on the setup that you want to make, mono or stereo, you can have multiple options. Let's first take a look how the mixer works. By clicking on the mixer icon of Dante channel 1, you will see that we have a lot of inputs that we can mix. We have the XLR 1, 2 inputs, we have our Bluetooth in left and right, and our 4-channel Dante in. And of course, our Dante out slider on channel 1. So basically here is what you decide to put on Dante channel 1 out. It's the same for Dante channel 2, 3 and 4. And by clicking directly in Audac Touch from this settings page to Dante channel output 2, I will get the same mixer settings for Dante channel out 2. That's how easy it is to configure. And you know in Audac Touch, by looking at the icons, volume and gain, you can access those settings directly by clicking on them. So when we talk about network sound, basically streaming audio over the network by Dante, we all made some setups that we, at certain point, ran out of flows. It's important that we talk about that and to know what chipset is behind our Audac devices. Like our Luna U and F, equipped with the Dante Brooklyn module, that will give you 64 channels or 32 flows. While all of our other equipment, which makes use of the Ultimo chipset, has 4 channels and 2 flows. So ANI 44 XT, ANX 44X, M203, the wall panels, they all use the Ultimo chipset. And keeping that in mind, I'll give you some examples where you might run into and how you can solve a fan issue, as that is called in Dante Controller. I have here a very simple example of one wall panel and one M203 mini stereo amplifier. They're both up, connected to the network, taking power over Ethernet. And let's see how we subscribe the audio channels. By making a subscription for my wall panel to my amplifier, I will create one flow that can hold up 4 channels. Now, M203 mini stereo amplifier, Dante Ultimo based, maximum 2 RX flows, 4 channels, and on my wall panel side, Ultimo based, 2 TX flows, 2 RX flows, 4 TX and RX channels. So far so good, this will work. Now, let's get rid of the network connections and focus on the Dante flows. Let's say I want to add another wall panel. That will create a second flow in Dante. Meaning that for my 4 channels, I have now 1 channel running on top, 1 flow, and from the wall panel I will use 3 Dante channels. But what would happen if I add a third one? That will give me a fan out in Dante Controller, and it will tell me, look, your receiver side, the amplifier, only accepts 2 Dante flows. You want to create 3. This will not work. But there's a solution. So, if you paid closely attention to the wall panels, you heard me talk about incoming Dante channels. And if we use those, the third wall panel, that I make a flow or a connection subscription to my second wall panel, this will create 1 flow. Meaning that I can mix that channel in my second wall panel and send it out as a third audio channel to my amplifier. How is this possible? Well, we talked about that thanks to the internal mixing possibility, where I can choose from 4 Dante channels besides my Bluetooth connection, my mini jack connection, and the XLR connections. Now remember, this is still a network setup, meaning that all devices are hooked up to the switch. The Dante flows are not physical connections. They are subscriptions that are made in Dante Controller. So, what comes out of the box when you buy a Luna? depends, difference Luna U, Luna F. Well, for the Luna U, we will not provide Dante channels, but you can buy an additional network module that gives you 8x8 Dante, expandable up to 32 by 32. For the Luna F, out of the box 16 by 16, and again, software license, expandable to 64 by 64. The other licenses that we provide regarding Lua scripting and acoustic echo cancellation, I'll give you a brief overview. So, Lua scripting, software license, 4 channels acoustic echo cancellation, software license, the 8x8 network license for additional Dante channels, and then we have a Dante network module, which is actually a physical board that we provide that you can slide in the Luna to get 8x8 Dante channels. And on top of that, buy additional licenses to expand. The last one in our product range is our paging table NPM 200. It's a Dante AES67 paging table that sends over the Dante network. It has a configurable touchscreen that can be tailored from Audac Touch, a base XLR that fits any microphone you like with phantom power, customize push-to-talk button with visual feedback on the LEDs, and powered over Ethernet. Let's take a look at the block schematic to understand how the signal flows from a Dante paging table. On the left side, we start with our XLR input that comes from a microphone with phantom power. We also have the chime input and a message input that allows you to broadcast any message you like. The incoming Dante channels are used to bypass the Dante channel and can be used by the NPM 200 to transmit its paging. So the phantom power XLR input comes into the NPM 200 with the gain control and wave tune, so you have EQing on your microphone. Your chime input and your message input have a volume slider before they enter the mixer. And the mixer output is actually put on the Dante channel by a bypass. So it interrupts the incoming Dante channel and puts its own paging message on that Dante channel. How would this look in Audac Touch? Well, basically the same. You will get an interface in Audac Touch with some buttons that you can customize. You can have multiple panels that can be swiped on your paging table. You can even look for individual zone paging, or you can group buttons with a click of a button that you can address multiple zones. Since our paging table also uses the Dante network to page and to transmit its audio, let's also talk about Dante Flows for the paging table. And again, let me show you with a very simple example. In this setup, we have the central switch where 3 of my paging tables are connected to. They can draw power over Ethernet, and I have 1 Luna connected to the switch. Now, my Luna uses the Dante Brooklyn chipset, so 32 flows, 64 channels. Paging tables, Ultimo based, 4 channels, 2 flows. Let's get rid of those network connections. And in this setup, how many tables can I connect? It's very easy because Luna accepts 32 flows, meaning I can connect at the same time 32 paging tables. And they can all individually page at the same time. It gives me a minimum latency on my Dante network. But what if I want to connect more paging tables? Well, you can simply daisy chain them and let each paging table decide for itself when it wants to page. Of course, if this is a daisy chain structure, meaning that although I'm not limited to 32 paging consoles, I can only page one by one on a priority base. And if I unplug one, the chain is broken. But again, it allows me to connect more than 32 paging consoles. And of course, it's still a network configuration, so the Dante flow is not the same as the network flow. Okay, wonderful. But I have more Lunas. Let's take a look at that. 3 paging tables, 2 Lunas. Connecting each paging table to the first Luna, and again connect to the second Luna, will give me 2 flows on each paging table. It's unicast. Although the Luna will accept 32 flows, I run out of flows on my paging table. Again, minimum latency. I can page all tables at the same time, but connecting a third Luna will give me problems because the paging table cannot provide more than 2 flows. So how can we solve this? You already know the answers. We have to switch to multicast. And by creating a multicast, I have one paging table that addresses the 3 Lunas, second one does the same, and the third one can also connect. So I have reduced my flows. Even better, on that multicast, I can daisy chain multiple paging tables. Of course, on each chain, you will have to respect the priority of the paging tables. And again, it is still a network connection, so every device is individually connected to the switch. I'm happy to show you one, let's say, real-life example in the field nearby, here in Laagdal, where Nike's offices are located. So the European Logistics Center with different plants next to each other. And this system was eventually, we were very happy with that, equipped with our old M2s with their peripherals. It's a system that has been running for many years with a high reliability. However, looking at the future and expanding, the system needs an upgrade. And we're very happy that our Luna has been chosen to be equipped in the Nike departments. So basically what it's about is that we have the ELC located and it's connected to the court and wings, 2 other plants. And every plant is equipped with multiple racks, equipped with M2s, with sources connected to the network. It's controlled by Audac Touch. Like here, connected to the court with, again, a whole bunch of racks with M2s installed. And the third plant, wings, again, with a whole bunch of racks. Now, the system runs on Audac Touch page, meaning that somebody at the desk is able to select on the floor plan different zones, and that can be used for paging. Even better, they can broadcast messages or speech by just clicking on the zones, clicking on a specific file that they want to play, and hit the play button. Or just use the plain page button. And this was a very complex setup. And it started actually from 23 M2s, because there were a lot of zones. In the future, when implementing the Luna, we can reduce the amount of M2s to only 8 Lunas, all controlled over the network. And in that new setup, where we implement our new paging tables, our switches, you will see that the original racks equipped with the M2s are highly reduced by some of them only switches, and other ones still have the XMP as a source, Lunas. So it's drastically reduced the amount of rack space that is used. Also for the different plans, you will see only 4 racks now. And for wings, also reduced. And this shows the possibilities that you can have with that new Atellio family. Remember, it's all about reducing and making or getting the most out of that zone system in the Luna, connected to all those outputs. Let's take a look at some other examples. Slightly smaller. When we talk about a centralized setup, that means we talk about one device that handles or processes all of the audio. So let's say I have a production area with an amplifier and an NCP 105 connected to the network switch. We have a second zone, the warehouse, where we have a PMQ 480 equipped with an ANI 44XT and also a network control panel. Maybe they want to change the source and the volume connected to the network switch. And the offices, well, an NWP, so they can make connection to the wall plate, paging microphone, and again an NCP 105 to control that zone. Now, this is not yet centralized. We're missing something, and that is of course a source, but also our Luna F, and that makes the system a centralized system. All audio and all traffic going on is handled by the Luna. Of course, we want to control that by Audac Touch. And how would a simple dashboard to control that system look like? Well, you can have your 3 zones with a volume slider, with the zone slider for production, warehouse, and the offices, together with the source selection. And notice that the offices uses a mixed input. And on top right, we have the mixer settings where my XLR inputs, my jack and my Bluetooth, are mixed together and transmitted as a Dante channel. And on top left, you see the station that we're listening to. We have our favorites on our dashboard we can select from. We have an album cover that shows me Soundtrack Your Brand that's streaming. This dashboard, in the way that it shows, can be created in, let's say, 10 minutes. That's how easy it is. However, you don't need to go centralized. We talked about that. You can also have a decentralized setup. Let's say I have a counter with an AM203, an MPM 200, with a network switch connected. I have a warehouse with a PMQ 240, equipped with an ANI 44XT Dante module. And I have the storefront with an NWP series, an M203, and an MFA. Again here, there is no Luna involved. Yet, all of these devices individually can work on their own. Meaning that the MFA with the NMP40 can stream its audio, all the zones can listen to that, the NVP can stream its audio over the network, where all of the amplifiers can listen to, while the MPM 200 can do the paging in all zones, without having one centralized processor handle all the traffic. Again, a simple dashboard for this. We have a counter where Soundtrack Your Brand is streaming with a volume slider, For the warehouse, the same, the storefront, and the NWP mix, where you have your 2 microphones and your Bluetooth. Soundtrack embed streaming, very simple dashboard for a decentralized setup. So we're almost at the end of the presentation. But there's one thing left to do, and that's show you how in the Luna, the input blocking, that zone blocking, and the output blocks, how they interact with each other. And the best way to show you is actually by an example. Let me show you. We have our inputs, our zones, and we have our outputs. And let's say that I want to create a very simple zone where I have a monozone mapped to different outputs with different wave preset filters. Because remember, on the output section, and since a zone output is not a physical output, we can assign it to one or multiple outputs, meaning I can do output processing on each of them. In this case, wave preset filters. First, we need a source. So let's map physical input 1 to zone 1, together with input 3, and map it to the output 1, where I load a wave preset for a VEXO 8. But I also want to map that output directly to a Dante channel, where again I want to load the preset file for the VEXO 110A. Second example for maybe, let's say, a monozone, again mapped to different outputs, but we want to use different delays. I can use an input that's already been used in another zone. That will not be a problem. So let's take again input 1. And also that input 3 that's already been used. And on top of that, Dante channel to input 3 of my zone. We map it to an output, in this case physical output 2, and we specify a delay of 0. I also map it to another zone with a delay of 50 meters. And the third one mapped to a flex channel with a delay of 100 meters. Now these were monozones, but again, you can also use a stereo zone. And a stereo zone means, of course, I need to have a left and right. And remember, on the Luna, you have to respect 2 inputs next to each other. So use 1 and 2, 3 and 4, and so on and so on. So let's use the flex channel 1 and 2 as a left and a right. Also 2 Dante channel inputs that can be stereo. And map it to a top left on the Dante output. We put a filter on that, high pass filter, and the top right goes to a Dante channel 3, again with a high pass filter. And the wonderful thing about mapping stereo zones is that on the end or the output of your zone, you will not only get left and right again, but you will also get the sub mono signal, and that can be used for a sub. So I want to assign that sub signal to a flex channel where I put a low pass filter on. Notice that on the input section where you use your left and right signal, that not only on your zone output that sub mono signal is present, but also on your input. And that signal can be used as a other zone input, for zone 1 for example, or zone 2. If you have a mono signal that you want to assign to a stereo zone, pick it up. Flex channel mapped to input 5 and 6 of zone 3. And this shows exactly the possibilities between the interaction between your input blocks, the output blocks, and your zones. So actually, between those blocks runs some kind of audio bus that you can pick from. This gives us a really flexible structure inside the Luna. So everything is interconnected, and you just pick the channel that you want to use in a zone, whether on a zone or directly to an output. Okay, let's hide the bus structure again. Let's say I don't want to make use of a zone, but I have an analog input that I want to put on the Dante channel. That's possible. You just pick the analog input and map it directly to an output, bypassing the zone. But what you can also do is, if you have a Dante channel that you want to extract in the Luna and put on a physical output, you can map a Dante channel directly to an output, flex channel or analog output. A zone output can also be used as an input for another zone. In this case, zone 1, the exit, which is already mapped to my analog output and a Dante channel, can also be rerouted to zone 2 and used as an input. What about acoustic echo cancellation? Remember, there was a 4-channel. Let's pick one out. So on my near end in and my far end in, they're also part of that bus structure, as well as my near end out and my far end out. So what can be used as an input and an output on the AEC block? Well, I can use the Dante channel as my far end in. Or I can use an analog input as my near end in. It can be a microphone. But why not use a zone output? Remember, we have a small conference room with 3 microphones next to each other. You want to locally mix them and use those 3 microphones as your near end in on your acoustic echo. That is possible. On the near end out and far end out, you can send out to your Dante channel or directly to an analog output flex channel. But again, your near end out can also be rerouted to zone input and have further processing enabled before it goes to an output. And the wonderful thing about this is that graphically, this will all come back in Audac Touch, showing the flexibility of the system, where I can see in Audac Touch, when I click here on zone 1, immediately that my 5 line inputs are mapped to that zone 1, and line output 1 uses zone 1 output to transmit. So by clicking on zone 1, or clicking on line 1, or clicking on line output 1, you will see the mapping that's going on inside the Luna directly from Audac Touch. And configuration has never been so easy to do in Audac Touch. So I want to thank you guys for joining in on this level 1 presentation. And if you want to get a hands-on on the equipment, on the Luna and everything else, make sure you come and visit us for that level 2 experience. Thank you for watching, and I'll catch you next time. Bye.